Imagine being able to step into a machine, set a dial, and suddenly find yourself in the distant future, or the far past. Time travel has fascinated humanity for centuries, but is it truly possible? What if I told you that the answer lies in some of the most mind-bending concepts in physics like wormholes and the nature of space-time itself? Today we're diving deep into the science of time travel, exploring the mysteries of wormholes, and discovering if our universe might allow us to journey through time. Buckle up, because this could be the start of an incredible adventure. Let's start with the concept of space-time, the very fabric of our universe. In 1915, Albert Einstein shook the world with his theory of general relativity, which tells us that space and time are woven together, forming a four-dimensional fabric that can bend, twist, and curve. Massive objects like stars and planets create dips in this fabric, curving space-time around them and creating what we feel as gravity. This means that space and time aren't fixed, they're fluid, responsive to the forces acting on them. And here's where it gets really interesting. If space-time can bend and stretch, could it also be manipulated to create shortcuts through time? One of the most intriguing possibilities is the idea of a wormhole. Think of a wormhole as a tunnel through space-time, a shortcut that could connect two distant points in space. Imagine folding a piece of paper in half and poking a hole through it. The wormhole would be that hole, providing a way to move instantly between 2 points that would otherwise be light years apart. If such a wormhole could be created and stabilized, it might allow for a form of time travel. In theory, you could travel from one end of the wormhole to the other, and if each end experienced time at different rates, because of their positions or speeds relative to each other, you could end up in the past or future. But while wormholes sound like science fiction, they're actually supported by Einstein's equations. However, there's a catch. Creating a stable, traversable wormhole would require something called exotic matter with negative energy, a type of matter that would keep the wormhole open and prevent it from collapsing. Exotic matter has been theorized but never observed. If it exists, it might be the key to creating and sustaining a wormhole. Without it, any wormhole we create would collapse almost instantly, making it impossible to travel through. Now, you might wonder if there's another way to time travel without the need for wormholes. And there is, at least in theory. Time dilation, a concept also predicted by Einstein's relativity, means that time moves differently depending on the speed at which you're traveling and the strength of the gravitational field you're in. For example, astronauts on the International Space Station who are traveling incredibly fast relative to Earth experience time a bit slower than we do down here. So technically, when they return, they've experienced a small jump forward in time. While this effect is tiny at the speeds we can currently achieve, it raises an incredible possibility. If we could reach speeds close to the speed of light, time would slow down so drastically for the traveler that they could potentially leap hundreds or thousands of years into the future in a matter of minutes. But traveling backward in time? That's much trickier. Many scientists believe that time travel to the past might be impossible due to paradoxes, like the famous grandfather paradox, where going back in time and changing events could have unpredictable consequences. Quantum physics offers some fascinating insights, suggesting that maybe parallel timelines or alternative histories could exist, where changing one event would create a whole new timeline. However, this remains purely theoretical. Ultimately, while time travel into the future through time dilation is possible in theory, we don't yet have the technology to make it happen in any dramatic way. And as for wormholes, there's still a tantalizing possibility that remains just out of reach, dependent on unknowns like exotic matter. But every step we take in understanding the nature of space-time and gravity brings us a little closer to unlocking the mysteries of time travel. Until then, time travel remains one of the universe's greatest mysteries, a challenge that pushes us to dream and imagine. So, keep wondering, keep questioning, and who knows, one day, we might just crack the code of time itself. If you found this journey through time and space as thrilling as we did, be sure to like, subscribe, and join us for more cosmic explorations. Because out there in the depths of space-time, anything might be possible.